Hi, I'm Mrs. McTaggart. In this video we are going to look at the first couple of lessons in differentiation. Rather than make 3 individual videos, I've put kind of the 3 first lessons all together into one. So what is differentiation? I'm going to look at the basic rules first of all. Differentiation is a topic in maths that a lot of people will actually maybe use in real life again. It comes under the heading of calculus, and it's probably one of the most important of all maths topics. It's used by mathematicians, scientists, statisticians, inventors, engineers, lots of different things like that. So what is it? Basically, the derivative of a function with this notation f of x, it measures how the function changes as x changes. And in the context of the graph, it's a measure of how steep a curve is. Isaac Newton was one of the famous mathematician and astronomer in the 17th and 18th century. He's rumoured to have invented calculus while studying the movement of the moon around the earth and the planets of the solar system. So it all comes into that, and basically normally to calculate the speed, for example, you would do your distance divided by the time, but if the speed of the object is always changing, that calculation can't be carried out, and that's where differentiation comes in. So here is a kind of rule and notations we use for differentiation. When we differentiate an expression, the rule is you multiply by the power and you lower the power by 1. And it's shown here in 2 different ways with the black and the red pen. So this notation on the left-hand side is if I give you an expression in terms of f, the derivative of this function is written as f dashed x. And what we do is whatever the power n was, you bring it to the front and then you lower the power by 1. We can also do it with an expression that starts with y equals instead of f of x. Remember, we always tell you these things are interchangeable. But the derivative or notation for differentiating y becomes dy by dx. And that just means you are differentiating y in respect to x. And again, we're timesing by the power and we'll lower the power. The easiest way to see this is through some examples. So let's go. So for each of these, we're starting nice and simple. We're just finding the derivative of the following. So f of x becomes f dashed x. And you times by the power 7, so 7 comes to the front. You keep the x as it is, but that's 7 lowers by the power of 1, which gives you 6. That's why I was saying 6 a second ago. On this one, same again, the notation becomes f dashed x. This time we have a number in front of the x already, so we're doing a half times 4, so we're multiplying them. A half times 4 is just 2, so this gives us 2x, and you lower the power 4 to the power 3. That's you. You've done your first couple of differentiation questions. Okay, on my next couple, we're doing the same again. Now this one here, notice there is no x term here at all. So technically when there is no x term, what you've really got is x to the power 0. Because remember, x to the power 0 is the same as 1, right? So that's just 6 times 1. And if you were to multiply them, that would give you x 6 to the power 0 would be 0. It would just give you 0, and it would give you 0 times x to the negative 1. But 0 times anything is just 0. So actually what we can do is we can just ignore this bit and know that anytime you differentiate just a number, the differentiated term is just 0. So it's almost like the number disappears when you differentiate it. So it's only the x's that will leave something behind. Okay, and this next one, we're going to differentiate. Don't be put off that there's more than one term. You're going to do each thing individually. So we're going to do an f dashed x. So we're going to do 2 times 2 is 4. Lower the power, it just becomes x to the power 1, but we don't write the power 1. On this one, when we've got 3x, remember that's it got a power 1 on it just now. And you're doing 1 times 3, which is just negative 3. Lower the power would take you x to the power 0. But we know x to the power 0 is 1, so we don't actually have to write anything there. So it just becomes 3. And then the number 1, when you differentiate it, there's nothing there. So watch out for these two. If you've got like a single power of x, that would just go to the numerical value. And if you have like a number, that would just go to 0 when you differentiate it. And you'll get used to that the more you do these. And then second last question, we've got a bracket here. Now later on you get shown another way to differentiate this, but right now, the minute you see brackets squared in maths, you have the inclination to do this, don't you? And if we multiply that all out, we get 9x squared. you get -6, -6, you get -12x, and then you get +4. Now we're ready to differentiate, so that just needed a wee bit of preparation first. So times by the power, 9 times 2 is 18. Lower the power, it just becomes 1, which we don't write. On this one, remember that's a secret power of 1, so you've just got -12. Lower the power is x to the 0, so nothing there. And then when you differentiate the 4, there's nothing there as well. So that one there, a trinomial, will go from 3 terms to 2 terms when you differentiate. My last question or example, and what would be my first lesson in differentiation before sending you off to practice, is this one here. Find the rate of change at x equals 3. So this is us trying to put it into context now. We're trying to find the rate of change or the shape of this quadratic when x has a value of 3. So what we do is we still do it the same. We do f dashed x as normal. So 4x to the power 4 times by 4, lower the power becomes cubed. Times by 2, so we've got -24x, lower the power just becomes 1, which I'm not going to bother writing, and then 36 disappears. So they've told us x is 3, so rate of change is another fancy word for just get the derivative. So we're doing f dashed of 3, and all you do is sub in the number 3. So it's like functions again from Nat 5. So we do 4 times 3 cubed, take away 24 times 3, 4 times 3 cubed, but that's 4 times 27, so 108. And take away 72. And the answer there is 36. Yeah, 36 for that one. And that would be the end of lesson 1. Time to go practice some basic differentiation. And then lesson 2, I would come in and I would say, right, okay, we've sussed that. We're now going to do it with ones with negative powers and fractional powers. So to be able to do this one, you need to be really, really good at your National 5 rules of indices. So a little reminder that if you have anything like 1 over a m, that is the same as writing a to the power of -m. So anything with a on the bottom can be rewritten with a negative power, and then that also works both ways. If you end up with a negative power at the end, you can take it down below and make it positive again. So these are all the same. So sometimes you have to go from this to this in order to differentiate, and then at the end they want the answer with positive powers, particularly if you're going to do some substitution, so you then have to go back to that stage again. So there's a lot of conversion using that rule. Now the other rule that you might not like from National 5 was the fractional one, where you had to power m over n. So that was the same as me giving you the nth root. So remember, the bottom becomes the root, the top letter stays put, so it's the bottom one that travels. And then in reverse, I might give you it in this form, and to be able to differentiate, you need to get it back to the form and remember that the root becomes the bottom of your fraction. So again, you need to keep interchanging between these two rules. So to differentiate, as I said, it has to be in power form, but you also have to have the x up on the top line. So if you look at my first example, you'll notice the x is not on the top line at all. So we're going to have to do a preparation line first of all and bring this up. So that is the same as x to the power -7. Then we do the rule as normal. To differentiate, we times by the power, so we've got -7 out front. Then we lower the power, and be very careful, -7 lowered goes to -8. And then all my questions we're going to write using positive indices, because a lot of times in differentiation you have to substitute in, which you cannot do unless you've got it in the form with positive indices. So positive indices means that the x travels to the bottom, so that 7 stays where it is, and that becomes x to the positive power of 8 for the first one. Okay, for the second one, again, we need to prepare this one. So the nth root, so we've got the third root, so we've got x to the power 2/3. So remember, the root is the one that moves over, so that one comes over there and goes underneath the fraction. Now we can differentiate. So we are going to times by the power, which gives us 2/3 out the front. When you lower the power, be careful, 2/3 take away 1. It's always sometimes good to think of this as, like, turn it all into thirds, and think of 2/3 take away 3/3, which obviously gives you -1/3. And that's it differentiated. But to write this positively, well, the 2 would stay on the top, the 3 is on the bottom, and the x comes down and becomes a power 1/3. Alright, now there is an alternative to that one. You could also write that bottom line as 2 over 3 and then times the cube root of x. But I would only do that if you were to do substitution. This answer here would be perfectly acceptable if it was just a straightforward differentiate question and leave with positive indices. But if you're going to have to put in a value of x at the end, you probably have to rewrite it using the roots again. These are tricky. Okay, let's step it up a bit. Let's bring in negatives and fractions and things together. So on this one, we need to prepare it again. So we need to bring the x up to the top. So we've got minus 1/5. We're now ready to differentiate. So remember and write down your f dashed x equals times the power. So we have minus 1/5 x. Now lower the power, remember, minus 1/5. I always take away 1 by thinking of taking away 5/5. And it's okay to go do that at the side if you need to. So that would give you negative 6/5. And then to write that using positive powers, well, the minus 1 stays on top. The 5 goes down below along with the x. And I'm just going to leave this one as 6/5 because it's very unlikely you would have to plug that one in to something like that. If you did, though, it would be the 5th root of x to the power 6. Okay, question D, we have to prepare it again. So remember, the square root is really got like a little 2 out front. We just don't write it. So this is the same as 3x to the power, that's got a secret little 1 there as well, so it's a power of a half. It's just really handy to remember square root is a half, cube root is a third, etc. Okay, now we're going to differentiate, so f dashed x equals, you have to do 3 times a half, so just leave that as 3 over 2. X, 1/2 minus 1 would be like 1/2 minus 2/2, which would give you minus 1/2. When you have to write that using positive indices, then you keep the 3 on the top, the 2 goes on the bottom, and then you've got x to the power of half, or you could write that as 3 over 2 square root x. But as I say, this answer is perfectly okay unless it is a question that's going to involve substitution, which we are not quite at just this minute. Okay, 2 more to go. Right, first one has a lot of prep to do, but be aware it is only this bit that comes to the top. The half stays as it is, so you might want to just keep that as a half out the front just now. This would come up and become x to the negative 4. We are now good to go. So you have negative 4 times a half, or a half times negative 4, which is negative 2. Minus 4 lowered goes to minus 5. This is actually a much nicer one to tidy up. So remember the number stays on the top, the x goes below, and it becomes negative 2 over x to the power 5. Next one, this is the power 4 goes to the bottom of the fraction. So this is x to the 3/4 we're being asked to differentiate. So f dashed x equals times the power, there's no number in front, so just 3/4. X, now 3/4, take away 1 is like 3/4, take away 4/4. So you have minus 1/4. To write it using positive powers, 3 stays where it is, 4 is on the bottom already, and then you have x, and that becomes positive power of 1/4. So that's me finished that style of question, so it would then be time to stop and go practice some of them. And the third and final lesson is just doing a wee bit more complicated differentiation questions. So some of these have got a bit more preparation to do at the beginning. Some of them have maybe more than one term in it. So let's have a look. I've got 4 examples. Let's see how we go. So the first one, 2 separate terms. The first one's good to go, but that second one is not in the right form. So we need to rewrite this. Now don't start to differentiate until you've got absolutely everything rearranged. This is the issue. A lot of people want to rewrite this one first. Now actually in hindsight, there's another way to think of this one. X over 4 could also just be written as a half x to the 4, and that might be a nicer way to look at this one. We're going to bring the x to the top, and that will become negative 1. And then you just differentiate the 2 things individually. So we do f dashed x equals a half times 4 is 2. And then lower that 4 to 3. We have a minus 1 to multiply. So watch your signs are going to change here. So this will become negative 1x, but I'm not going to write the 1. And then the minus 1 would drop to minus 2. And as always, I want to write everything with positive powers. So the first one's okay, it's already done. And on this one, the x would go down below, and that would turn to a positive power. Okay, second one. First thing's good to go, second thing not so much. So we're going to leave the 9x squared. Remember the 4 stays in the bottom, so I'm going to write this one as 1/4, and then x to the -2 comes up. Now we're ready to differentiate. So times by the power, lower the power, just takes us to 18x. Times by the power here, 1/4 of 2 would, or 2 times 1/4 would be 2/4, which is just the same as a half. We're also times by a negative, so this gives us -1/2. X, the -2 lowered goes to -3. And then as always, writing it with positive powers gives you 1 over, the 2 goes to the bottom, so does x. Sorry, the 2 was already on the bottom, and the x goes below and becomes +3. Okay, right, C is a really important one. You see this quite a lot. You have 3 terms there, all divided by x. So remember, you can split them back up. So if I cast your mind back to when you were doing, if you were doing change of subject and you had 3y equaled 2x plus 4. And asked you to change the subject, you would then just say y equals 2x plus 4, all divided by 3. But if you were doing a straight line question, that's for change of subject. But if you were doing a straight line question, you would go and actually divide everything by 3 individually, so you could get the gradients. You would say, oh, that's 2/3 of x, and that would be 4/3. They're both the exact same thing. So if something's all over 3, you can split it up and do everything divided by 3. So the same rule applies here. You can just separate absolutely everything up and divide it by x. Now, please don't try and skip lines of work in here. Write them all out individually over x first of all, because it's really easy to make a wee mistake. So I'm going to write them all individually as over x. Then we're going to simplify. So x squared over x just gives me x. 5x over x just gives me 5. And then the end one, the x would come to top and be a power of -1. So a wee bit more prep involved here. Now we're going to differentiate. So when you differentiate x, it just becomes 1. And remember, that's because that's really x to the power 1, which becomes x to the 0, which is just 1. So it's just 1. The 5 differentiated disappears. And then we're differentiating the end terms. So we're doing -1 times -3 turns into a +3. Lower the power goes to -2. And to write it using positive powers, it's 1 plus 3 over x squared. So that's that one all done. Okay. On my last example, I'm going to rewrite that bit in the bracket. First of all, remember square root is a power of half. And we're going to multiply out the bracket now. So remember, when you're multiplying, you add the powers. So 2 plus a half is 2.5, which as a top-heavy fraction is 5 over 2. And then that's just take away 2x squared. Now we're good to differentiate. So what's your notation? Remember, write down f dash x equals, or dy by dx. I noticed none of my examples have started with y equals. I really should think about that for when I'm teaching it in class. So for times by the power, it becomes 5 over 2, bracket x. Now when you're lowering this one, remember 5 halves, take away 1 is the same as taking away 2 halves. So that becomes 3 halves. Times by the power gives you 4. Lower the powers is power 1, which I'm not going to write. So there's a lot in this video. I know it's one really long video, but it's covered all of the differentiation stuff you've missed, and you should hopefully have access to a textbook or worksheets to do some practice on this. Thanks for watching. I hope it's helped. Good luck.